You ever wonder why some of the smartest people in tech still make catastrophic decisions? How billion-dollar platforms collapse from a single overlooked variable? Or why fixing one issue in a product can suddenly break five others? That's not bad luck. That's a failure to think in systems. In the world of technology, we've trained ourselves to solve problems fast, but not to step back and see the machine as a whole. Systems thinking is how we stop treating symptoms and start addressing root causes. It's not a buzzword, it's the lens that separates short term hacks from long term transformation. And in tech, it's the difference between building tools that work and building systems that endure. Chapter 1: The Blind Spot in the Machine. Most people working in tech have been trained to think in parts. You break the problem down, fix one piece at a time, push a patch, ship the product, move on. But what happens when each part interacts in ways we don't anticipate? What if the problem isn't in the part, but in the pattern? Systems thinking begins by flipping your perspective. Instead of treating each issue like a standalone event, you start asking, what is this a symptom of? What's the system that made this outcome inevitable? And here's the uncomfortable truth: most of our tools, processes, and even metrics are designed to ignore the system. We reward fast fixes, not structural solutions. In software engineering, this shows up all the time. A server crashes, and you restart it. It crashes again. And now you add more capacity. Still fails? Add load balancers. But no one stops to ask, why is it crashing in the first place? You could be masking a deeper issue like unoptimized queries, memory leaks, or flawed assumptions about user behavior. You're putting out fires without asking where the fuel is coming from. This kind of thinking also shows up in org structures. A team misses a delivery deadline, so management adds more check ins, more dashboards, more pressure. But maybe the issue isn't about visibility. Maybe it's the fact that teams are overloaded with dependencies or working in silos that contradict each other. Systems thinking forces you to zoom out and ask, what structure produced this behavior? And can we redesign the structure, not just to react to the behavior? Tech is full of feedback loops. Some are reinforcing, others are balancing, and many are invisible until something breaks. A buggy release triggers user complaints, which leads to a rushed fix, which introduces new bugs, which leads to more pressure and less testing. And so the loop continues. Without systems thinking, you chase your tail endlessly, wondering why nothing ever stabilizes. This isn't just an engineering thing either. Look at social media platforms. A feature designed to boost engagement, like infinite scroll or algorithmic feeds, can lead to user addiction, mental health issues, polarization. The original intention was neutral or even positive, but in complex systems, effects emerge from interactions, not just intentions. That's the heart of systems thinking. You learn to map not just cause and effect, but circular causality. It's not A causes B. It's A causes B, which feeds back into A, amplified by C and D along the way. Without this mindset, we build solutions that solve nothing and introduce new problems. Think of AI systems that are trained on biased data, then used to automate decisions, which then reinforce the same biases, which go back into the training data. That's not a glitch, that's a loop. And if you don't see the loop, you become part of it. Engineers who don't practice systems thinking end up firefighting their whole careers. Architects who don't use it create structures that can't adapt. And leaders who ignore it end up managing symptoms while their organizations decay underneath. If tech is the engine of change, systems thinking is the steering wheel. You can't afford to ignore it. Chapter 2: From Linear Thinking to Loops. Linear thinking is seductive because it's simple. You identify a cause, you expect an effect, push a button, get a result. It's how most of us are trained to solve problems: find the root, pull it out, and move on. But when you're dealing with code bases, platforms, teams, markets, or ecosystems, nothing actually works in a straight line. Everything loops back. Everything influences everything else. Take something like product adoption. You roll out a new feature. It's supposed to increase user engagement. At first, the metrics spike. Great. But over time, you notice something weird. Customer support tickets rise, user retention drops. Turns out the new feature made the interface more cluttered. More people clicked initially, but more people also got confused and frustrated. What looked like a win was actually the start of a reinforcing feedback loop in the wrong direction. In systems thinking, you don't just ask what will happen, you ask what else might happen. You map loops, you anticipate delays, second order effects, unintended consequences. It's like debugging the future. Instead of asking what's broken, you ask what's the structure that keeps creating this result. The tech industry struggles with this because we worship speed. Move fast and break things became a mantra, but the systems we work within don't reset just because you pushed an update. In fact, the faster you move without feedback, the more blind you become to the loops you're triggering. Technical debt is just a slow loop catching up with you. Culture debt, same thing. These are delayed feedback systems. You don't feel the pain until it's hard coded into everything. Let's zoom in on organizational loops. A developer notices a flaw in how the sprint is planned. Dependencies aren't accounted for. They flag it, but no one acts. The team works around it. Over time, workarounds become normalized, bad planning becomes cultural, and eventually, even new hires internalize this behavior. Now, you're not just dealing with a process issue, you're in a cultural loop. Fixing it isn't just about changing the sprint board, it's about breaking the cycle of normalized dysfunction. This shows up in leadership too. Managers incentivize quick delivery over quality. Teams cut corners, bugs rise, trust falls. Managers then double down on deadlines to compensate. That's a reinforcing loop. The only way out is to change the structure of incentives, communication, and learning. But that only happens if someone sees the loop. If no one's looking, everyone thinks the system is just how things work. In AI development, we are now seeing some of the biggest and fastest feedback loops in tech history. A model performs well, gets deployed, affects user behavior, generates new data, which is then used to train the next model. The boundary between training data and real world impact blurs. What used to be separate cycles are now one massive spinning loop. And when those loops start amplifying biases, toxicity, misinformation, it's already too late to go back and fix the training set. You've created a system that's training itself and maybe mistraining all of us in the process. Thinking in loops also changes how you think about failure. In a linear mindset, failure is a mistake. In a systems mindset, failure is a signal. Something in the loop is off. Something in the structure is producing behaviors that no one intended. If you ignore the signal, you don't just miss the fix, you risk scaling the failure. This is where causal loop diagrams come in. They're not just academic tools. In real world tech environments, mapping these loops helps you see what's invisible. You can chart delays, unintended side effects, points where pressure builds up. You begin to predict how the system will react before you intervene. And that changes how you solve problems. You stop asking, how do I fix this one issue? You start asking, what structure can I redesign to make this issue disappear on its own? The best tech companies, the ones that scale and last, operate like living systems. They learn, adapt, self correct. And that's not magic. That's intentional design. It's choosing to build feedback into your product cycles. It's creating safe loops for failure before they turn catastrophic. It's teaching every engineer, PM, designer, and exec to stop thinking in straight lines. Linear thinking can ship a feature. Systems thinking builds a company. One is a short term game, the other is how you stay relevant when everything changes. Chapter 3: How Systems Thinking Can Reshape the Future of Tech. When you start applying systems thinking, the whole terrain of technology begins to look different. You stop obsessing over individual metrics and start asking how the entire landscape is wired together. The questions change. It's no longer, why did we fail to launch on time? but what loop are we trapped in that made delay inevitable? Not how do we increase engagement, but what trade offs are built into our definition of success? You start seeing product features not just as tools, but as agents within a system that will provoke a set of reactions. A simple notification setting might affect user behavior, which affects retention, which influences monetization, which shapes the next set of features. Each small tweak becomes a ripple in a tightly wound network. That's not just product design, that's system design. And it's what the smartest teams are doing already. Nowhere is this more visible than in large scale platforms. Think of something like Uber. At surface level, it's an app that connects drivers to passengers. But dig deeper, and you're looking at a web of interdependent systems, driver incentives, rider demand, traffic flow, pricing algorithms, regulation, even public opinion. When Uber adjusted driver bonuses in one city, it impacted wait times, user satisfaction, and eventually market share. A single lever triggered a cascade, and without a systems view, they wouldn't have seen it coming. Another example is content moderation on platforms like YouTube or TikTok. You can't just moderate one video at a time. What you promote or ban creates loops, behavioral loops, algorithmic loops, cultural loops. Promoting engagement without context trains creators to chase clicks. That behavior feeds the algorithm. The algorithm reshapes culture. Now, you're not moderating content, you're shaping what people believe. This is not a side effect. This is systems dynamics in action. Even the move to decentralization in tech, blockchains, DAOs, edge computing, is a shift in systems thinking. Instead of centralized control, you design rules and incentives so that local behavior produces global order. That's a systems problem at its core. You don't manage every node. You build a structure where desirable patterns emerge organically. But to do that, you have to deeply understand the loops, the trade offs, the feedback that drives the system. In climate tech, we're starting to see the same mindset take hold. It's not enough to build cleaner factories or smarter grids. You have to understand how energy usage, economic behavior, policy incentives, and even cultural norms feed into each other. A heat map of emissions is also a map of system relationships. Change one node and you might shift the whole network, but only if you know where to push. Tech's next breakthroughs won't come from better code alone. They'll come from better perception, from being able to see the whole instead of just the parts, from building platforms that learn and adapt like ecosystems, not just like machines. Systems thinking is what lets you design for complexity, not just in spite of it. And it's not a tool you add at the end, it's a mindset that shapes everything from day one. It changes how you write specs, how you run retros, how you measure success. It makes you less reactive and more anticipatory. It helps you zoom out when everyone else is stuck zooming in. This is especially critical as we enter an era of convergence. AI, biotech, quantum, climate tech, they're not siloed anymore. They're colliding, creating hybrid systems with unpredictable interactions. You won't be able to isolate cause and effect. You'll only be able to trace patterns. In that world, systems thinking isn't a luxury, it's a survival skill. The irony is, the more powerful our tools become, the more fragile our systems can get. A single decision in a single team can ripple across continents. One poorly trained AI model can affect millions. The stakes have never been higher, but neither has the opportunity. If we choose to see the loops, not just the lines, if we train ourselves to map structure, not just chase symptoms, if we build systems that learn, adapt, and balance rather than break, then tech stops being a race against collapse and becomes a framework for resilience. That's what systems thinking offers, not a fix, but a shift, not control, but clarity. And in a world getting more complex by the minute, clarity might be the most powerful tool we have. Thanks for tuning in. Until next time, stay curious and keep asking better questions.